everyone, this is Kalpana here. In this video we are going to solve a differential equation from higher order linear differential equation. So let's get going. Problem: solve d square minus 3d plus 2 into y equals to cos 3x cos 2x. Solution. So firstly, let's find order and degree of the given equation. So identify the highest derivative. Here d square is the highest derivative, so order will be 2. The highest power of the highest derivative is our degree. So our degree will be 1. Or you can just write the given equation as d square y minus 3dy plus 2y equals to cos 3x into cos 2x. We know that differential operator d equals to d by dx, then d square is d square by dx square. So now we can write d square y as d square y by dx square minus 3 into dy as dy by dx plus 2y equals to RHS. Right? Now identify the highest derivative. Here d square y by dx square is the highest derivative. So our order will be 2. And the highest power of the highest derivative is our degree. Degree is 1. Right? Now coming to the problem. We are given a differential equation which is in operator form. Given differential equation d square minus 3d plus 2 into y equals to cos 3x into cos 2x, which is in operator form. F of d into y equals to q, where f of d equals to d square minus 3d plus 2 and q equals to cos 3x into cos 2x. Now we need to find the general solution to the given equation using y equals to yc plus yp. Here yc is a complementary function. We'll find yc using roots of the auxiliary equation of the homogeneous equation of the given non-homogeneous equation, and we'll find yp using 1 by f of d into q. Right? So how we'll get homogeneous equation? Simply take this RHS as 0, then we'll get f of d into y equals to 0, which is a homogeneous equation. Okay, now let's find the complementary function using the auxiliary equation. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we are having f of d equals to d square minus 3d plus 2, right? So we can replace d by m, differential operator d by m, to get f of m, which is equals to m square minus 3m plus 2. Now our auxiliary equation becomes m square minus 3m plus 2 equals to 0. Now split minus 3m as minus 2m minus m plus 2 equals to 0. Now take m common from the first two terms. You'll get m times m minus 2, and take minus common from the next two terms. You'll get minus of m minus 2 equals to 0. If you notice, we are having m minus 2 in both the terms, so let's take m minus 2 common. We'll get m minus 2 into m minus 1, which is equals to 0. Now we equate each factor to 0. If you equate the first factor to 0, you'll get m equals to 2. If you equate the second factor to 0, we'll get m equals to 1, right? So m equals to 2, 1, or m equals to 1, 2 are the roots to the given, not given, to our auxiliary equation. Therefore, m equals to 1, 2 are the roots of f of m equals to 0, right? Our auxiliary equation, which are real and distinct. So now we need to write the complementary function using the roots. We know that when two roots are real and distinct, say m1, m2 are real and distinct, then we can write complementary function as constant into e power 1 root into x plus another constant into e power another root into x, right? Now let's write our complementary function. Y is equals to c1 e power 1 root, say 1 into x plus c2 e power another root into x. So therefore, y is equals to c1 e power x plus c2 e power 2x is a complementary function. Now we can find particular integral. We know that particular integral is given by yp equals to 1 by f of d into q. This is equals to 1 by f of d. We have d square minus 3d plus 2. And q is cos 3x into cos 2x, right? We know that cos a minus b plus cos a plus b equals to 2 cos a cos b. Or we can just write it as 2 cos a cos b equals to cos a minus b plus cos a plus b, right? Now take this 2 to RHS, we'll get cos a cos b equals to 1 by 2 into cos a minus b plus cos a plus b, right? Now since cos a cos b equals to 1 by 2 into cos a minus b plus cos a plus b, then what will be the value for cos 3x plus cos 2x for a equals to 3x and for b equals to 2x? We'll get 1 by 2 into cos a 3x minus b 2x plus cos a 3x plus b 2x, which is equals to 1 by 2 into cos 3x minus 2x is x plus cos 3x plus 2x is 5x, right? Now we can replace cos 3x into cos 2x by 1 by 2 into cos x plus cos 5x, right? Since cos 3x into cos 2x equals to 1 by 2 into cos x plus cos 5x. Now this becomes 1 by f of d into 1 by 2 into cos x plus cos 5x, right? Now we can write this yp as constant 1 by 2 into 1 by f of d, that is d square minus 3d plus 2 into cos x plus cos 5x, which is equals to 1 by 2 into 1 by f of d into cos x plus 1 by f of d into cos 5x. Okay, we can just name one term as some yp1 and the second term, okay, first term as yp1 and second term as yp2 for our convenience. So we'll get 1 by 2 into yp1 plus yp2. Now let's find yp1 and yp2. Firstly, yp1, which is equals to 1 by d square minus 3d plus 2 into cos x, which is in 1 by f of d into cos ax form, right? Now let's find d square, which is given by minus a square. For a equals to 1, you'll get minus 1 square, which is equals to minus 1. Now consider f of d or 1 by f of d. Now replace d square by minus 1 and see whether the denominator is not equals to 0 or equals to 0. Firstly, we are going to check 1 by minus 1 minus 3d plus 2. Okay, we'll replace only d square by minus 1. Okay, then we'll get 1 by minus 1 plus 2 is 1 minus 3d, which is not equals to 0. Right? It is not equals to 0. So what we can do? We can just replace d square by minus 1 square, which is equals to minus 1. Then we'll get 1 by, I'm again writing the same steps here. Just replace d square by minus 1, then we'll get minus 1 minus 3d plus 2 into cos x, which is equals to 1 by minus 1 plus 2 is 1 minus 3d into cos x. Right? Now what we'll do is, see in the denominator we are having 1 minus 3d, or simply in the denominator we have something pd, which is in pd plus q form. Then we'll just multiply and divide with pd minus q. Okay. So here multiply and divide with 1 plus 3d. Here you're having 1 minus 3d, so we'll just change this sign as plus and we'll multiply and divide to the fraction. Then we'll get 1 plus 3d by 1 plus 3d into 1 minus 3d into cos x. Right? So here we have denominator which is of a plus b into a minus b form, which is a square minus b square. You can write, right? Since we know that a plus b into a minus b equals to a square minus b square, so we'll change the denominator. We can write denominator as 1 square minus 3d whole square into cos x, which is equals to 1 plus 3d by 1 square 1 minus 3 square is 9 into d square cos x. Again d square appears in the denominator, so what we have to do, we'll again check with d square. Just consider 1 minus 9d square and replace d square by minus 1 and see what we are going to get. We'll get 1 minus into minus plus 9 into 1 9 equals to 10, which is not equals to 0. Okay, always we have to get something not equals to 0 in the denominator. If we get something equals to 0, then the expression divided by or by 0 becomes undefined. Okay, denominator must be not equals to 0. Now we got to know that 1 minus 9d square after replacing d square by minus 1 is not equals to 0. So we can replace d square by minus 1. Okay, 1 plus 3d by, after replacing d square, again you'll write the same steps here. Just replace d square by minus 1 into cos x, which is equals to 1 plus 3d by 1 minus into minus plus 9 into cos x, which is equals to 1 plus 3d by 10 into cos x. Again, you can write this as, we can just split this as 1 by 10 into 1 plus 3d into cos x. Okay. Now we are having yp1 equals to 1 by 10 into 1 plus 3d into cos x, right? So we can write it as 1 by 10 into 1 into cos x is cos x plus 3d cos x. We know that differential operator d equals to dy dx. Then we can write this d as d by dx of cos x, right? Equals to 1 by 10 into cos x plus 3 into derivative of cos x is minus sin x, right? And this becomes 1 by 10 into cos x plus into minus minus 3 sin x. Therefore, the value of yp1, that is 1 by f of t to cos x, is 1 by 10, right? Therefore, equals to 1 by 10 into cos x minus 3 sin x. Now let's find yp2. yp2 equals to 1 by f of d into cos 5x, right? This is also in 1 by f of d into cos ax form for a equals to 5, right? So firstly, let's find d square, which is given by minus a square, which is equals to, for a equals to 5, you'll get minus 5 square equals to minus 25. So consider 1 by d square minus 3d plus 2 and replace d square by 25, that is minus 25, sorry. Okay, we'll get 1 by minus 25 plus 2 is minus 23 minus 3d, right? You can just write this as minus 3d minus 23 otherwise. Now, take minus common from the terms of denominator. You get minus 1 into 3d plus 23, right? We can just write this as minus 1 by 3d plus 23, right? Which is not equals to 0, right? Denominator is not equals to 0 after replacing d square by minus 25. So what we'll do now? We'll just replace d square by minus 5 square, which is equals to minus 25. Then we'll get 1 by, again we can just write these steps. Replace d square by minus 25, you'll get minus 25 minus 3d plus 2 into cos 5x, which is equals to 1 by minus 25 plus 2 is minus 23 minus 3d into cos 5x, which is equals to 1 by, now take minus common from the terms of denominator, you'll get minus of 23 plus 3d into cos 5x, or we can just write these terms as, here we wrote minus 3d minus 23, right? You can write term involving d first and minus 23, which is equals to 1 by, now take minus common, you'll get minus of 3d plus 23 into cos 5x, which is equals to minus 1 by 3d plus 23 into cos 5x, right? Now we are having yp2 equals to minus 1 by 3d plus 23 into cos 5x. Now we are having 3d plus 23 in the denominator, so what we'll do, we'll just change this plus sign to minus and multiply and divide with 3d minus 23. into cos 5x, right? Equals to minus 3d minus 23 by, you're having 3d plus 23 into 3d minus 23 into cos 5x, which is equals to minus 3d minus 23 by, the denominator is of a plus b into a minus b form, which is equals to a square minus b square, right? For a equals to 3d, you'll get 3d whole square minus, for b equals to 23, you'll get 23 whole square into cos 5x. Now we can write this as minus 3d minus 23 by 3d whole square, 3 square 9 into d square minus 23 whole square, 23 into 23, 3 3s are 9, 3 2s are 6, 2 3s are 6, 2 2s are 4, you get 9, 6 plus 6 12, 529, 529 into cos 5x. Now let's see what happens if we replace d square by minus 25 in the denominator. Okay, I'm just going to consider the denominator 9d square minus 529. Now we'll check whether I'm going to get equals to 0 or not equals to 0 by replacing minus 25. Okay, by replacing d square by minus 25. 25 nines, 9 5s are 45, 9 2s are 18, 18 plus 4 22, minus 225 minus 529, right, which is equals to 5 plus 9 14, 2 plus 2 4, 4 plus 1 5, 2 plus 5 7, minus 754, which is not equals to 0. So now we can replace d square, right? Since we got to know that the denominator after replacing d square by minus 25 is not equals to 0, so we can dare to replace d square by minus 25, right? Then we'll get minus 3d minus 23 by 9d square. We'll just replace d square by minus 25. Then we'll get 9 into minus 25 minus 529 into cos 5x, which is equals to minus 3d minus 23 by 9 into minus 25. Just write these steps. Minus 225 minus 529 into cos 5x, which is equals to minus 3d minus 23 by minus 225 minus 529 is minus 754 into cos 5x. Now we can write this as equals to minus into 1 by minus 754 into 3d minus 23 into cos 5x, right? So we can write 1 by minus 754 as minus 1 by 754 into 3d cos 5x minus 23 cos 5x, which is equals to minus into minus plus. You'll get 1 by 754 into 3 into, we know that d equals to d by dx, right? Then we'll find derivative of cos x, that is cos 5x with respect to x minus 23 cos 5x. We'll get 1 by 754 into 3 into derivative of cos 5x is minus 5 sin 5x minus 23 cos 5x. Then this becomes 1 by 754 into minus 3 5s are 15 sine 5x minus 23 cos 5x. Now let's take minus common from these two terms, then we'll get minus of 15 sine 5x plus 23 cos 5x. Right? Finally we'll get minus 1 by 754 into 15 sine 5x plus 23 cos 5x. Therefore, yp2 equals to minus 1 by 754 into 15 sine 5x plus 23 cos 5x. Right? Now, coming to yp. We have yp equals to 1 by 2 into yp1 plus yp2, right? Now let's write the results obtained from yp1 and yp2. Result obtained from yp1, that is 1 by f of t into cos x, is 1 by 10 into cos x minus 3 sine x plus yp2. Result obtained from 1 by f of t into cos 5x is minus 1 by 754 into 15 sine 5x plus 23 cos 5x, which is equals to 1 by 2 into 1 by 10 into cos x minus 3 sine x plus into minus 1 by 2 into 1 by 754 into 15 sine 5x plus 23 cos 5x, which is equals to 1 by 2 times 20 cos x minus 3 sine x minus 1 by 2 into 754. 4 plus 4, 8. 5 plus 5, 10. 7 plus 7, 14 plus 1, 15. 1 by 1508 into 15 sine 5x plus 23 cos 5x. Therefore, yp equals to 1 by 20 into cos x minus 3 sine x minus 1 by 1508 into 15 sine 5x plus 23 cos 5x. Now we can write the general solution. The general solution is given by y equals to yc plus yp. Then y equals to yc, we have c1 e power x plus c2 e power 2x plus yb 1 by 20 into cos x minus 3 sine x minus 1 by 1508 into 15 sine 5x plus 23 cos 5x. This completes the problem. So we have seen a problem from higher order linear differential equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.